Q8934. An anti-skid system is designed to A. Solely sense the deceleration rate of every main landing gear wheel. B. Release then reapply pressure at a slightly lower value when a skid is detected only. C. Sense the deceleration rate of every main landing gear wheel and release, then reapply pressure at a slightly lower value when a skid is detected. The correct answer is C. Sense the deceleration rate of every main landing gear wheel and release, then reapply pressure at a slightly lower value when a skid is detected. The correct answer is that an anti-skid system is designed to sense the deceleration rate of every main landing gear wheel and release and reapply pressure at a slightly lower value when a skid is detected. The system continuously monitors the wheel deceleration rates during braking. If it detects an impending or actual skid, it modulates the brake pressure by momentarily releasing and then reapplying the pressure at a slightly lower value. This action helps to prevent the wheels from locking up and reduces the risk of skidding while maintaining effective braking. Q8935. In a brake anti-skid system, when an approaching skid is sensed, an electrical signal is sent to the skid control valve which A. Acts as a bypass for the D booster cylinders. B. Relieves the hydraulic pressure on the brake. C. Equalizes the hydraulic pressure in adjacent brakes. The correct answer is B. Relieves the hydraulic pressure on the brake. This option describes one of the functions of the skid control valve in a brake anti-skid system. When an approaching skid is sensed, the skid control valve releases or relieves the hydraulic pressure on the brake momentarily. By reducing the pressure, the valve prevents the wheel from locking up and skidding. Q8936. An anti-skid system is A. A hydraulic system. B. An electrohydraulic system. C. An electrical system. The correct answer is B. Warning systems in electrohydraulic system. This option describes the more accurate nature of an anti-skid system. An anti-skid system is typically an electrohydraulic system, meaning it combines both electrical and hydraulic components. Electrical sensors and control units are responsible for monitoring the wheel deceleration rates and sending signals to hydraulic valves or actuators. These hydraulic components then modulate the brake pressure to prevent wheel skid. Q8937. Anti-skid braking systems are generally armed by A. The application of brakes. B. Switch in the cockpit. C. The rotation of the wheels above a certain speed. The correct answer is B. The brake anti-skid system can be armed by positioning the arming switch to the armed position. This action disengages the brakes and activates the locked wheel protection circuit. Once the anti-skid system is armed, the brakes will remain disabled until the aircraft's weight is fully on the wheels and the wheels have attained a rotational speed exceeding 15 to 20 miles per hour. This ensures that the anti-skid system is operational only under appropriate conditions. Additionally, the same switch provides the pilot with the ability to deactivate the system when necessary. This allows the pilot to have control over the anti-skid system, enabling them to activate or deactivate it as required for safe and efficient braking operations. Q8938. A typical takeoff warning indication system, in addition to throttle setting, monitors the position of which of the following? A. Ailerons, elevators, speed brake, and steerable fuselage landing gear. B. Elevators, speed brake, flaps, and stabilizer trim. C. Aerodynamically actuated slats, elevators, flaps, and speed brake. The correct answer is B. Elevators, speed brake, flaps, and stabilizer trim. This option presents a more relevant set of components that are typically monitored by a takeoff warning indication system. The position of elevators, speed brake, flaps, and stabilizer trim directly influence the aircraft's aerodynamic configuration during takeoff. Monitoring these components ensures that they are properly set for the intended takeoff conditions.